Rule number 5 is the product rule. The product rule tells you how to take the derivative of the product of two functions f times g. And the result ends up giving you f prime g plus fg prime, which, as I said, is a little bit easier to recognize as this, f prime g plus fg prime. We'll prove this using the limit definition of the derivative. There are also really cool geometric ways to interpret this. And in fact, if you haven't already found these guys already, look up a YouTube channel called 3 Brown, 1 Blue. Or is it 3 Blue, 1 Brown? I always mix up the colors. But either way, some combination of brown, blue, and the numbers 1 and 3. They have a whole bunch of awesome videos that explain calculus concepts in kind of easy to understand, often geometric terms, and they're awesome. So look these guys up on YouTube. They have great explanations. Our proof will not be the area explanation that these guys do. Instead, we'll just do the more formal limit definition. So we begin with the derivative of f times g, which we know from the limit definition is the limit as delta x approaches 0 of our function when you plug in x plus delta x, so f of x plus delta x times g of x plus delta x, minus our function when you just plug in x, so f and g, all over delta x. Now this appears to be kind of a dead end, and you have to do kind of a surprising next step to finish with the proof. You have to add and subtract the same term. And the term that we are going to add and subtract will be, we're going to add and subtract f of x times g of x plus delta x. So we'll subtract it down here, and then we'll add it right next to it. I wish I had scooted this over a bit. I'm out of space. I'll continue down here. And then minus f of x g of x, all over delta x. A little bit sloppy, but hopefully you can see it's just one continuous line on top. So we subtracted it and then added it, which means we didn't change the value of the expression at all. Our next step is to rearrange our terms in a clever manner that is beneficial to our proof. We're going to group these two terms together, and we're going to group these two terms together. And our goal is that when we do that, we'll end up with f prime g plus fg prime. So I'm going to put this all into one limit. When we group those first two terms in red, I'm going to factor out a g of x plus delta x. And I'm going to factor that out and write it on the end of the expression. So this is just those two terms rewritten. Everything is over delta x, so it's over delta x, plus the blue terms. And when I rewrite these terms, I'm going to factor out an f of x, and I'm going to put it in front. And I'm left with g of x plus delta x minus g of x, all over delta x. And so if you multiplied out these terms and added up the fractions, you would end up right back where we were in the previous step. But the reason we did that is because now we have what we want. This limit is f prime. As delta x goes to 0, this just goes to g of x, plus f of x just stays f of x. since when delta x goes to 0, this is unaffected. And this quotient is, of course, g prime. The change in g over the change in x as delta x approaches 0. And so that is the proof of the product rule. Just a clever rearrangement of your terms. The quotient rule, which we'll do next, is similar. It has a similar proof. For the last 8 or 9 years that I've been doing interphase, the proof of this has been a p-set problem. I don't know if it's going to be a p-set problem this year since we're doing the remote everything. So I won't actually prove this out, but the proof has a very similar twist that the proof of the product rule had, where you have to add and subtract the same term. What the quotient rule says is the derivative of f of x over g of x is f prime g minus fg prime all over g of x squared. Or f prime g minus fg prime over g squared. It's a horrible prime sign. Some students know this cool song about like high D, low, I don't even know it. But if you know that, that's cool because that's a good way to memorize this. I just know it as f prime g minus fg prime over g squared.